All right, I could use a little work, but hey, Gospel Changes by John Denver. What's life without John Denver? Right? Truly classic songs. John Denver and, of course, Weird Al. But anyhow, all right. So we were working on the study guide, starting with number 13. We'll also go through some things on the chart, but I think most of these stick more closely to the study guide here now. Number 13. We have two types of exercise. We have aerobic exercise, and we have resistance or isometric exercise. Now, this gets a little confusing because we already have aerobic and anaerobic respiration, all right, which both could be a part of aerobic exercise. And we have isometric contractions, but now we have isometric or resistance exercise. So try not to get these confused with the contractions that we have already talked about up here. All right, so what are the differences? Well, first of all, let's talk about aerobic. Aerobic, we think about aerobic a lot of times doing aerobics. Okay, that's hence the name. The idea is you're moving around a lot, you're moving the muscles, getting a lot of exercise, running, bicycling, so forth. You're actually exercising your muscles, doing stuff. It does involve aerobic respiration, but eventually if you do run to it very long, you probably switch over to an anaerobic, start getting lactic acid buildup and pain and all that sort of stuff. But here's the deal. The effects of it is this. If you have aerobic or endurance exercise, then you're going to have stronger but more flexible muscles. They're not bulky muscles. They tend to be longer and more flexible. They are stronger. They don't fatigue as easily. They can go a long time. It's the idea of endurance, that you can go a long time without getting fatigued and going into muscle fatigue. All right. You also usually have a stronger heartbeat, a more efficient respiratory system, so you don't have to breathe as hard and so forth. It takes less to get you huffing and puffing. Okay. All right. So that's aerobic exercise. Now, isometric or resistance training or exercise. Your aerobic will make your body more efficient. It burns food better, so it's just kind of overall healthier for you. It also improves digestion. I found out that this movement and doing all that stuff seems to help your digestion. Coordination, become more coordinated. All right, all those type of things. Okay, resistance or isometric exercise. Weightlifting would be probably one of the biggest examples. Okay, you're pushing something, a weight or something that resists it. Now, in this type of training, you're going to get larger individual muscles, okay? And it's because each individual muscle cell actually gets larger, okay? While in aerobics, they get stronger and more flexible, but they don't necessarily actually get bigger. So this is why a weightlifter all bulks up and showing his arm show, you know, whatever. He's going to be a lot more bulkier exercise. It's still healthy for you. It's not bad. It's not good. It's good or bad. It's just that it doesn't have a lot of the other benefits that come along with it necessarily with resistance training. Okay, so it increases your muscle size, your strength. It actually increases the size of the muscle fibers. Hence, that's why you bulk up and get bigger. Whoops, I thought there was another one there, but maybe not. Let me see. That's all we had. Okay, all right. So that's it. Sure has a question mark there, like it's going on to the next thing, but okay. Examples then, obviously, this is a marathon runner. Obviously, you can see he's got muscles, but is very slim, slender, endurance-y kind of thing. On the other hand, a weightlifter is going to have all the big bulked up muscles, okay? Health-wise, aerobic, like I said, is more healthy, but you can have, like, for example, say a football player may have a lot of isometric or resistance training, a lot of bulky muscles, but if they run a lot, then they can also have some of the benefits of both. But overall, if you're just going to do one or the other, it would probably be healthier to do aerobic exercise. All right. So some of the benefits of aerobic, kind of mentioned that already. That's number 14. More efficient body metabolism, improves your digestion, also moves elimination, which means it's moving your waste products out, otherwise known as pooping. Neuromuscular coordination, your nerves and your muscle system work together better, makes your skeleton stronger because when you pull on the bones, that strengthens up your bones. The heart pumps more blood, so you have better pumping, and it helps push fat and stuff like that builds up in your arteries. Just like if you have a water hose where you turn it up on high, if there's anything stuck in the hose, it's more likely to knock it loose. Okay, and so it can clear out the fat deposits and stuff that sometimes start to collect in your artery, especially as you get older. So exercise is very important. All right, now origin and insertion. Okay, anytime you have a muscle, you have two parts. All right, and so the origin is where it is attached to an immovable bone. Okay, now it depends on what the muscle is. Okay, for example, your biceps. Your biceps, the main job is to contract and pull your hand up like this. Now, your triceps on the bottom does just the opposite. When it contracts or get closer together, it pulls your hand back out. So you have these, we'll talk more about this, muscles that work in pairs or opposites. Okay, so for your bicep, when you pull it up, that's its job, then your humerus is your immovable bone. And so where it attaches to that would be your origin. Okay, now the movable bone, which in this case is your radius and ulna, all right, I think it's attached mostly to your ulna, but anyhow, that's where it's insertion. So this would be the origin of your biceps. This would be the insertion because that's the movable bone. Now, for your triceps, it would be the opposite, okay? This, it's pulling it back down here. I take that back. It would still be the same, sorry. Still the immovable bone's this, the movable bone's this. You're just moving it the opposite direction, my bad. Okay, anyhow, so origin is where it's attached to the one that stays still, in this case, the humerus, okay? And insertion is where it's the movable bone. Now, if you moved your elbow like this, now the shoulder would be the immovable bones, and that would be the origin, and the insertion of these muscles that allow you to do the chicken wing thing here would be that were attached where they attach to your humerus would be actually the insertion. So it depends what movement we're talking about, which one's the origin, and which muscle we're talking about, what's the insertion, and which one is the origin. All right. So on your drawing, then this would be first of all the let me see if I labeled all these. Yeah, I did. Okay. So first of all, the origin is where it's attached to the immovable bone. Insertion is where it's attached to the movable bone. All right. When your muscle is relaxed, it's spread out, and that allows your arm to go down. When it contracts, then it bunches up, and that pulls your arm up like this. Okay. And this, in this particular movement, we're talking this is your immovable bone. And down here would, of course, be your movable bone. All right? So make sure you have those labeled correctly. I can almost guarantee you that will be on the test. Now, one of the things we talk about with muscles, number 17, muscles can only pull. Okay, this muscle pulls, your biceps pulls your arm up. Your triceps pulls it down. It's not like, oh, my biceps pushes it back down. You can't push. It's like pulling on a rope. You can pull on a rope, but you can't push on a rope. Okay, if you have a horse or something on a rope, you can pull them forward, but you can't push them, okay, backwards. And so muscles can only pull, and that's why you have to have pairs. You have the biceps pulls it this way, the tricep pulls it back down, and using those two muscles to balance each other, then we can go halfway in between, because this one can be half contracted, and this one can be half contracted, and so it ends up somewhere in between there. All right, but muscles can only pull; they cannot push. All right, let me see, go back then. All right, we'll get to that in a minute, but define the following muscle terms. Prime mover, okay? For example, when I lift my hand like this, the main muscle responsible for that is the prime mover, or the biceps. It's the muscle that has a major responsibility for causing that movement. And so in this case, my biceps is the prime mover of that one. To go down, then that is the tricep. It's the prime mover of that one, okay? So depending on the movement, it depends on which one it is, but it is the one that mostly does the movement, we say. However, there are also antagonists, okay? So if I'm bringing up my hand, there's also my triceps is acting as an antagonist to my biceps, okay, and pulling back against it. And by balancing those two pulls, I can make my hand stop halfway or whatever I need to do, okay? So antagonists, just like in a book, you have the protagonist, the hero, and then have the antagonist who's against him. Well, in this case, you have muscles. In most movements we do. We have muscle pairs that oppose each other, and they kind of balance each other out. And so in this case, the triceps would be your antagonist. All right. Synergist, okay, help. Synergy means we work together, okay? When all of us are better than some of us or something like that. Something like that, I forget the saying. But anyhow, that synergy is when everybody works together, you can do more together, all right? And so in this case, synergists help the prime mover do the same movement, okay? And they may also pull on it and help assist it. So they're called synergists. They help. They also may keep other things from moving. For example, your shoulder up here, okay? You don't want it going like this while you're bringing your hand up, okay? So if you're doing curls, you want to just bring this up and you want to hold everything else still. So it can help hold things still, or maybe your wrist holds still, and that helps you to do the movement or whatever, okay? All right, now fixators are similar to synergists, okay? Synergists either help the same movement or they just keep other movements like your hand twisting side to side or something like that that's going to interfere with it. Okay, a fixator is they actually hold a bone still, okay, or stabilize the origin. In other words, while you're bringing this hand up, you also need something to hold your humerus in place so it doesn't go flopping around and stuff. Okay, so it holds it still or stabilize it, keep it so that the biceps can do its work that we want it to do. Okay, so that is a fixator. Okay, so they actually keep the origin still. Okay, synergists are more general. They either have other muscles that help with the same movement, or they keep other undesirable movements like twisting of your hand and other stuff there, but not the actual origin. Okay, all right. Which brings us to number 19. The terms for these: immobilizes the origin of a prime mover. That would be a fixator. Postural muscles, which are just things that kind of keep you in place, would be mostly fixators. They're holding things still so that we can maintain good posture. All right. 3, stabilizes the joints so the prime mover can act at more distal joints as a synergist. Okay. So, for example, if you want to write with your hand, then you might have some synergists that are keeping the rest of your arm still or whatever, so you didn't go flopping around at the same time. Okay. Number 4, performs the same movement as a prime mover and helps it out. That would be a synergist. And 5, reverses or opposes the action would be an antagonist. All right. So it's BB, DD, A, and the only one we did not use is a prime mover, which is the primary muscle responsible for a movement, but that was not a choice on there, so you did not use it. All right. Number 20. Why is it inaccurate to say that one muscle caused a particular movement? Basically because even though we say the bicep does this, there's all these other muscles that are helping. Antagonists that are balancing against it, synergists that are also helping do that, and fixators that are holding your humerus still so that you can do that movement. So all these work together. Antagonists, synergists, and fixators all help together to allow you to do the movement you want to do. All right. We are about to run out of time on this recording, so looks like we will have to go to at least one more, and we will see you on that one. Have a great day.